Okay, this is a quiz recovery for a quiz that you would have taken on November 21st. It was about solving and graphing inequalities. And one of the biggest problems right off the bat that occurred as I was grading these is that students forgot to graph the solution. And at least in my classes, I pointed that out to everybody the day before, that you're going to have to both solve and graph the solution. So hopefully that'll clear up some of it. So let's look. This is the practice quiz. It looks very much like the real one that you will recover and fix. But in first block, in my classes, we did this in class. Second and fourth block, we did not, being AIG. So if you watch this, maybe it'll help you to fix your actual quiz. So we're going to solve these just like equations with a few exceptions, and we will get to some of those. So in this case, I need x to be by itself. So I'm going to subtract 1 from both sides. This goes away. And x will be less than or equal to, same signs, add and keep, -3. And check and make sure your variable is on the left-hand side, and it is. And check and make sure you never multiplied or divided by a negative number, which you didn't. This was adding. And then you have to graph it. And like I told my students, you really only need 3 numbers. The number you need and 1 on either side, just to tell which direction you're going in. This is less than or equal to, so it's going to be a filled-in circle. And since my variable is on the left side, it's all ready to go, pointing in the right direction. So I just have to go like that. And you can test a number to be sure. Is 2 less than or equal to 3? Yes, it is. So we're good with that. All right. Let's try number 2. Okay, so number 2. We have -9n is greater than or equal to 0. So we're going to solve the inequality first. I need to get n alone, so I'm going to divide both sides by -9. So in this case, n is just going to be greater than or equal to 0. So again, we solved the inequality, but we still have to graph it. That's the next important thing. All right, so I'm going to need a number line. I'm going to need 0, -1, and 1. It's going to be a filled-in circle because these get filled-in circles and these get open circles. All right, and then my variable's on the left-hand side, so it should be pointing in the right direction, and I can test a number if I want to. Is 1 greater than or equal to 0? Yes, it is, so we're going the right way. All right, let's look at number 3. 30 is less than 10x. X is what I'm trying to get alone, so I'm going to divide both sides by 10. X is greater than 3. Now I'm going to graph it. Give me color. Okay, I need 3, and I need 2, and I need 4, and I need something else. I need the variable to be on the left-hand side. And you need to do that with a mirror image. So the greater than part of this symbol, this part right here, still needs to be next to the x. So it's going to be x is greater than 3. If you read it backwards, x is greater than 3, x is greater than 3. So now, this is pointing in the right direction. So I'm going to do an open circle on 3, because there's no equal to, and that is the correct direction. All right, let's move on. -4p is less than or equal to -12. All right, so I need to get p by itself, so I'm going to divide both sides by -4. And alarm bells should be going off because I am dividing by a negative number, which means I have to flip the inequality sign. This becomes a 1, and -12 divided by -4 is 3. That's how you solve it. So now I have to graph it. I need a 3, a 2, and a 4. I need to check and be sure that my variable is on the correct side, the left side, and it is. So that means this is pointing in the right direction. So I'm going to put a filled-in circle on 3, and I'm going to go to the right because that's the direction it's going in. And you can test a number Is 4 greater than or equal to 3? Yes. Is 3 greater than or equal to 3? Yes. All right, let's look at number 5. It's way down here. I'm going to rewrite it. 2 times negative 9 plus x is less than or equal to negative 50. So this is a multi-step inequality because first I have to distribute. So 2 times negative 9 is negative 18. 2 times x is 2x is less than or equal to negative 50. All right, so now I'm just going to solve it. My x's are over here, so I'm going to keep them over here. And I'm going to move my 18 over here. This goes away. 2x is less than or equal to negative 32. Hopefully that's right. I'm kind of tired. X isn't alone yet, so I'm going to divide both sides by 2. X is now less than or equal to negative 16. I never multiplied or divided by a negative number, so I don't have to flip my sign. And my variable's on the left-hand side, so I'm ready to graph. I need negative 16, and be careful, negative 17 goes over here. It's going to be a filled-in circle because it is one of these. And because my variable's on the left-hand side, this is going the right direction, so I just graph it. All right, one more for this slide. Uh-oh. Stopped working. Oh, there it goes. All right. Last one for this slide is 5 minus x is less than 10. All right, so first I'm going to move the 5. That goes away. And 10 minus 5 is positive 5. Now, I need some red. I cannot do that. That is not okay. I need it to be positive. And the fastest way to make that positive is to multiply both sides by negative 1. It's not actually changing the value, it's just changing the sign. So a negative 1 times a negative x is positive x. And 5 times a negative 1 is negative 5. But look what I did. I multiplied by a negative number, which means I have to flip my sign. That's a lot of steps to keep track of, a lot of places to make a mistake. All right, let's graph it. I need negative 5, negative 6, which goes on that side, and negative 4. It's an open circle because there's no equal to signs under the inequality sign. And my x is on the left-hand side, so it is pointing in the right direction. I'm going to pause here and do the next slide on the next video.